Hello viewers, this is Manas welcoming you to the series You the Oracle Expert, your one-stop shop to learn and practice Oracle database administration and Unix with hands-on experiments using Oracle VirtualBox virtual machines. Build your knowledge base, confidence, and make your way to be an expert Oracle DBA. In today's tutorial, we are going to create an OEM metric extension to detect spikes in Archivelog Generation in an Oracle database. The Archivelog Generation is dependent on transactions or changes happening in the database, and usually DBAs don't have control over that. And all a DBA can do is to find out what is the amount of Archivelog that is generated every hour or on daily basis using different SQL statements or other tools. The DBA's role is to back them up timely and keep them safe, so in the event of a recovery, we have all the archive logs available that we need. Usually, the archive logs are put in a location called FRA or the fast recovery area, or a file system designated as Archivelog destination, which is capable of holding them for a day or so. In this case, we are not using the dest parameter to define the Archivelog destination, and instead we are using a recovery area which is of size 100 gigs. Oracle recommends to use a fast recovery area to keep all the recovery related files for easier manageability. In this case, we are using a file location designated as fast recovery area, which is of size 100 gigs, and out of 100 gigs, we are using 16 gigs, and rest of the 84 gigs are available for us to use. The DBAs normally back them up in regular interval, like every 1 to 2 hours based on the need, and clean up the location, as if the archive location is 100% full, the database will go to a hung state, and we don't want that in a production database. But if there is a sudden rise in Archivelog generation due to bulk data delete or load or similar activity, a regular periodical backup may not be enough, and the Archivelog location may be 100% full even before the backup job runs and clears the location. To mitigate this kind of risks, DBAs keep a file system threshold based backup job that is triggered from a cron tab or an event manager program that backs up the archive logs and clears the location upon the file system utilization crosses a certain percentage, like 40% or 60%. But in both these cases, DBAs will never come to know that there was an incident like this and a spike in Archivelog generation has taken place. The OEM has given us a few options which are inbuilt and can be found under monitoring, metric collection, and settings to address this kind of issues, where there are two particular metric which can give us some direction when this kind of situation happens. One such inbuilt metric is the archive area usage percent, this particular metric, and the other is the recovery area usage percent. But these two metrics will trigger an alert even if the root cause is not due to Archivelog generation, because FRA may have other files like backup pieces and flashback logs also. Similarly, if a DBA temporarily copies a large file to the file system used as Archivelog destination, then also the metric used to detect the archive area usage will send an alert. But our goal here is to make the DBA aware of what is happening in his database environment, especially application or user activities, and to notify immediately upon detecting any anomaly. For example, if the application team started a massive data load or a data purge without notifying the DBA team, or an user by mistake issued a delete statement without putting a proper where clause, or dropped a table causing a massive amount of Archivelog to be generated, and there may be many more such examples. So here we are going to detect this kind of anomalies with the use of an OEM metric extension. As I have already explained about what is a metric extension, how and where we need it in a few of my previous tutorials. To save time, I will not explain them here again and will directly go to design and create the metric extension for today's tutorial. The links to my previous tutorials on how we can detect an alert on long-running SQLs or backup failures, etc. using metric extensions are given in the description of this video below. If you want, you can check them out using those links. So to create the metric extension, first we need a SQL statement with certain characteristics. And this is what the SQL should do. It will calculate the current Archivelog generation for a database in Archivelog mode. It will calculate the last 7 days Archivelog generation, excluding Saturday and Sundays, because those are the 2 days we do maintenance activities and we expect to generate more Archivelogs during those 2 days than on a normal day. Those 2 days Archivelog generation will adversely impact the average if taken into consideration. And third, it will compare the current Archivelog generation with the average we calculated above, and based on the increase factor, the metric extension will send an alert. What will be the thresholds on the increase factor that will categorize the alert as a warning, critical, or clear that we will define in the metric extension itself while creating it. I have already developed the SQL statement for you and I am explaining it below. You need to understand the SQL so you can make modifications to suit your requirement if needed. You can download the SQL statement or any of the SQL statement that I am using in this tutorial from my Google Drive, for which I have given the link in the description of this video below. In this query, I'm implementing subquery factoring using a with clause here, and there are 3 subqueries: T0, T1, and T2. T0 is finding out the log mode of the database, whether it's in Archivelog mode or no Archivelog mode. The second subquery, that is T1, is finding out the current day's Archivelog generation. And the third subquery, that is the T2, is calculating the last 7 days average Archivelog generation per day, excluding the Saturday and Sunday. And the final or the main query is joining these 3 subqueries and doing some mathematical calculation to find out what is the increase factor of the current day's Archivelog generation compared to the last 7 days Archivelog generation. It may be more than 2 times, more than 3 times, or it may be less than the average. So that is what the increase factor will give us. Now let's run this SQL statement. And for this particular database, it gives us an increase factor of 0.8, where the current Archivelog generation is 1.14 gigs and the last 7 days average is 1.42 gigs. So obviously the current Archivelog generation is less than the average, and that is what is reflected in the increase factors value here. And this increase factor will be used to compare with certain thresholds to determine whether it's a warning or a critical or a clear situation. Please note that we are not considering the databases which are not in Archivelog mode. And that's why we are using a decode function here to exclude those databases which is not in Archivelog mode. And now we are going to create the metric extension in OEM. First, go to Enterprise, Monitoring, Metric Extensions. Then click on this Create button, Metric Extension, and the target type in this case will be database instance. Name of the metric extension will be, say, Archivelog Generation check. Let's put the same display name, and the adapter will be SQL here, and we'll put a description like Archivelog Generation check. Now in the second box, the collection schedule, the data collection will be enabled, data upload will be yes, use of metric data, it will be used for alerting and historical trending, upload interval will be 1, frequency, let's set a frequency as whatever it is taking by default, because anyway we can change it later on if we want. So the collection frequency by default will be 15 minutes. Click on the next button. We'll simply copy and paste the SQL statement that we developed, which is already tested and was executed. Then click on the next button, and here we have to define 3 columns, and these columns are nothing but certain variables which are going to accept the values returned by the SQL statement. Please note that our SQL statement is actually returning 3 values. The first value is the increase factor. The second value is the current day's Archivelog generation. And the third value is the last 7 days Archivelog generation. So let's first define the first column by clicking on this add button, new metric column, and the name will be, say, inc factor. Same display name. The type will be data column. Value type will be number. You don't have to define any unit here. The category will be, say, utilization. Transient will be false. Comparison operator. Here we have to define our thresholds. Say when the increase factor is more than or equal to 2, then it will be considered as a warning, and when it is more than or equal to 4, then it will be considered as a critical. It means when the Archivelog generation on a particular day is more than 2 times the average of the last 7 days Archivelog generation, then it will be considered as a warning situation, and when it is more than or equal to 4 times the average Archivelog generation of the last 7 days, then it will be considered as a critical condition. Then manually clearable alert will be false, and number of occurrences before alert 1. Now we have to define the alert message and the clear message here. But before we construct our alert message or the clear message, let's define the other 2 variables which is going to be used for the current day's Archivelog generation and the average Archivelog generation returned by the SQL statement. So press the OK button here, and we will define a new metric column. And here we'll simply put the name as carvel, that is the current day's Archivelog generation. It will be data column, number, no units, category will be utilization again, transient will be false, and we will not define any thresholds for this particular variable here. So press OK, and then we will create the third column or the variable, which will be, say, average val. Display name will be the same, data column, number, no unit, category will be utilization again, transient will be false, and we will not define anything else for this particular variable again, and press OK. Now we go back to our first variable and modify the alert messages. We'll put a message here which will be more meaningful for us, like Archivelog generation. Instead of the column name here, we'll put carvel. This is in gigabytes, so we'll put GB there. Is percentage inc factor percentage times the last 7 days average of percentage avg val gb. To understand how this message will look like, let's take an example. Say on a particular day, the Archivelog generation is 6 gigs and usually your last 7 days average is say 3 gigs every day. Then you can say that there's a 2 times increase in Archivelog generation. And in this situation, this message will look something like that. The Archivelog generation 6 gigs is 2 times the last 7 days average of 3 gigs. And what the clear message will look like, the Archivelog generation is normal. Now let's press the OK button to complete the variables or the columns and press the next button. Use the default monitoring credentials in the next screen and click on next button. Now in this screen, we have a option to test our metric extension. To do that, click on this add button and select a target database instance. In this case, we'll select one instance which is currently up, that is the CatDB, and this is nothing but our OEM repository database. Press the select button, select the target again, and click on the run test button. And this gives us the results as increase factor is 0.93, current value is 1.32, and average value is 1.42. So our metric extension is working as expected. Now click on the next button and finish. Now we can see here in the list of metric extensions, our new metric extension is listed here as Archivelog Generation check. Now this metric extension is not deployed on any of the targets. We just tested on one of the targets to see if it works or not. Now to deploy it on any of the targets, first click on the actions and change the status to deployable draft by selecting this option, save as deployable draft. And once it is saved as a deployable draft, the next action will be to publish it as a metric extension so that other administrators or users in this OEM system can use it. So we published it and now we can deploy it on our database targets. In this example, I will deploy it on only one single target. To deploy it, select a metric extension and click on the deploy to targets. And in this list, we will add the same target on which we tested our metric extension. So we selected the target and click on the select button and click on submit. Refresh the page and the entry is gone, means it is successfully deployed. Now go back to metric extension page again and we see that our metric extension named Archivelog Generation check is deployed on one target. Now to see this metric extension in action, we will go to our target database first. And once you are in the target database's homepage, click on the Oracle database menu, then go to monitoring and metric collection and settings here. We should be able to see the metric extension that we just deployed as one of the metrics in this settings. So this is the metric extension that we just deployed, that is the Archivelog Generation check. And here to test it, we will have to lower the thresholds because as we have already seen that the SQL query upon testing is not returning a value which is more than 2 or 4, and that is not going to create an alert for us. So we will reduce it to something like say 0.5, and let the critical threshold be 4 because we just need to test it against just one warning alert. And instead of running it every 15 minutes, let's reduce the frequency to 1 minute so that we immediately get an alert. Put it as 1 minute. Click continue. It will complain about the repeat interval being very low. That's okay for one-time testing. Click continue and click OK button again. Now, whether an incident has been created by the metric extension or not, we'll go to Oracle Database, Monitoring, Incident Manager. And we can see that one warning alert is created here. Let's select it and see the details. This is created less than 1 minute before. Click on this event tab and click on this latest events again, and that will give us all the details of whatever activities have been performed. So we can see that in the last comment here, we can see that an email was sent to my Gmail ID as per the rule set that I have defined. Please note that sending an alert to a particular email ID or performing predefined actions based on the alerts is actually defined in the incident rule sets, which is not covered in this tutorial. Creating an incident rule set is altogether a different chapter, which I am going to cover in a different tutorial. So for now, we can see that our metric extension is working and it has sent a warning alert to my email ID. Now let's go to my email and check how the alert message looks like. In my personal email inbox, I have a rule set to redirect all the alert messages coming from the OEM system to a particular folder, that is OEM Manash, and I can see that there is one latest alert message from OEM, and let's open and check what it is saying. And it is saying exactly what we wanted it to say. The Archivelog Generation 1.49 GB is 1.05 times the last 7 days average of 1.42 GB. So our metric extension is working exactly as we designed it to do. And now we will go back to our OEM system and change the thresholds and the collection frequency back to the original values. Go to the target database's homepage, monitoring, metric collection and settings. This is our metric extension, and put the warning threshold back to 2 and the collection frequency to 15 minutes as earlier. Click the continue button, click OK, and we are all set. So viewers, I hope you enjoyed the video and found it useful. Please hit the like button if you liked it and subscribe to my channel so you won't miss an episode in this series for the Oracle DBAs or similar educational videos that I am uploading every week.